found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Good morning, everyone. My name is Georg, and I'm welcoming you on this third day of our WeAreDevelopers Congress. I hope you had a lot of fun the past 2 days, but not only fun, but also insightful talks, cool workshops, amazing opportunities to connect with other participants or our partners. If you didn't get to it yet, check it out in the Swapcard app. There are many possibilities to connect with other people, to visit the booth of our partners, and of course, to check out the program, just like today. We have a full day planned with amazing talks, keynotes, and of course, workshops. And for all of you blockchain enthusiasts, I know that you are because you signed up for this workshop, we will start with a gem. We will start with this 2-hour workshop now powered by Lisk, where you will learn how to build a blockchain application with a Lisk SDK. This workshop will be about 2 hours. It will be interactive. If you have any questions that you want to ask our speaker, please do that in the chat, and we will either do it right away or save it to the end. Of course, if you also have something to add up, some things you want to bring on the table as a point of discussion, please do that. Try to make the most out of it for you. And with that being said, I think it's time to get our speaker on stage. As said, from Lisk, please welcome Manu.
Hey, George. Thank you very much for the introduction. Glad to be part of the WeAreDevelopers event. And
thank you for being here. Thank you for doing this session. I hope you are excited as we are.
Yeah, I'm very much excited to have this workshop where we are demonstrating how you could easily bootstrap your own blockchain application within a couple of hours, and build your use cases with the blockchain, which is right now trending in the industry, and then which addresses a lot of problems and challenges that face in the industry right now related to could be financials or any other industries. So yeah, I'm very excited to.
Yeah, we have 2 hours. Let's see how fast we can be.
Yeah. I'm hopeful that we could get something done before the workshop.
Then I will let you start now. I will jump backstage, and if there are any questions, I will notify you. Otherwise, we will save them for the end.
Sure. Thank you.
Cool. Take it away.
I would share my screen. I hope everyone can see the screen. So, hey, my name is Manu, and I'm lead backend developer at Lisk. I've been working with Lisk since 2018, and we are working on SDK and platform products for the development of blockchain application in general, which encompasses for you to either build white label blockchain applications, or in the coming months or years, you will be able to build a sidechain application using the Lisk SDK. So today we are going to look into how you could develop your own blockchain application using the Lisk SDK in a couple of steps within a few hours or a few steps of use cases that we're going to use. So before we move on to the further steps, I would like to give you some time to look into the prerequisites. I have posted the prerequisites, how to install them, in the Swapcard chat, and please go through the steps and then prepare for installation. We will still have some time before we start the workshop again, but yeah, meanwhile, if you have something to do in the background, so you could still go on and install the prerequisite for the workshop. And having said that, so for me, today's agenda is I'm going to give you some announcement related to the Lisk grant program and Lisk core testnet release. And then I would give you an overview of the Lisk SDK product. And then we will build the blockchain application using the Lisk SDK, this new bootstrapped feature that we've been released in 5.1.1. And we will take a use case with supply chain traceability and then try to use the Lisk SDK to build the supply chain traceability with the minimalist version of it. And then we will have the Q&A session post the session. So this is the agenda for me today. And so what is the Lisk grant program is all about? So Lisk grant program is a way for you to showcase your blockchain application skills using the Lisk SDK. You could build use cases of blockchain using the Lisk SDK. Lisk will grant you 60,000 chef paid in Lisk tokens, and then the grants will be paid in 4 milestones. So what are the requirements for the grants program? You need to have a founding team with at least 2 founding team members, and then have minimal knowledge of JavaScript at least. And then you need to have the spirit to take it as not as just a proof of concept, but to making it as the real world blockchain application, which is really important for us. And then you need to pitch your idea and then provide all the business plans that you have for this, the idea that you have, and then present a pitch. And then you need to keep the blockchain application that you've been developing up to date, and it should be open source completely. So these are some of the requirements to be able to participate. So here are some of the suggestions for the developing the blockchain application use case. So if you're in the blockchain industry, you might have already aware that these are some of the use cases that are being trying to solve, such as lending markets, stable coins, NFT marketplace, and collectibles, prediction markets, social network, DAOs, oracles. So these are some of the suggestions using which you could build your ideation and then propose and work on. So how do you approach? You can go to the list.com grant program, where we have defined the clear steps and process how you could apply for the grant program. And check out our YouTube channel, where the marketing head, Monica, talked in detail about how the grant program works, and then all of that is available in the YouTube channel. And yeah, I look forward to you to apply for the grant program. So now moving on to the Lisk core announcement. So in the past months and year, last 1 year or so we've been working really hard on making the core protocol related to the blockchain fully implemented, so that we move on to the interoperability phase, meaning that once we have all the underlying protocol developed done, then you could have the scalability, and then all other benefits that comes with interoperability can be achieved with the next couple of versions. So the Lisk core 3.0 basically covers all this basic protocol features one require to either bootstrap your own white label blockchain application, or use that as a sidechain in the Lisk ecosystem. So it brings new dynamic fee system, address system, new consensus algorithm. So there are much more features that is coming with the Lisk core 3.0. We have conducted multiple beta releases, and it's going to be released tomorrow. I'm really excited, and then the team is also very much excited about this release. So that's all about the announcement. So now let's move on to Lisk SDK and understand what Lisk SDK is all about. And so Lisk SDK is a set of compromise libraries that you can use to create your own blockchain application. For example, Lisk Commander, which we will use in the workshop later, you will understand and see why Lisk Commander is important. For developers, Lisk Commander is an entry point where you could bootstrap your blockchain application and then interact with the blockchain application. And the the commander is utilizing this framework and then libraries that is provided beneath for you to build the on-chain and off-chain logics, which I'm going to explain later in the stage. So I would like to explain the three important architecture traits that we have in order to achieve the the bootstrapping in blockchain application, or in order for the blockchain application to work. So we categorized into on-chain, off-chain, and communication architecture, where the on-chain architecture mainly takes care of the protocol related for the blockchain. For example, once the for any transaction happens on the blockchain, and then the transaction is included in the block, so it's never get it's tamper proof, and then it never rolls back. And all of this kind of protocol related logic is handled in the on-chain, and we're going to use this on-chain logic to in our supply chain use case. You will understand a bit more detail further. Off-chain logic is something you could monitor the activities within the on-chain as well as the other off-chain plugins, and provide services or metadata to the third-party developers or desktop and any other products which want to use this metadata to show information. And communication architecture allow you to interact between these off-chain processes and then on-chain and off-chain processes. This is the architecture of the framework. So as you can see, we have the application in the top layer, which is coordinating the on-chain and off-chain communications. And then on the on-chain, you could see the node is acting as an orchestrator for all the business logic that is being handled, whether it could be state mutation or downloading the blocks from the networks and then synchronizing it. All of this being handled on the on-chain. And modules are the way for you to implement your own custom logic on top of the blockchain and extend the blockchain logic and develop the use case. Off-chain logic allows you to have the concept of plugins where you could monitor the activities in the on-chain as well as the off-chain to off-chain communication, and then listen to these events via channel, and then build, observe the data and then build metadata on top of it. You could build, a lot of use case. For example, you could build a HTTP API service. You could build, an autonomous, a bot kind of service to report some activities. You could build a monitoring service. So these are all some of the possibilities that you could do in off-chain. So what would the on-chain architecture comprises of? So as we saw, Lisk module concept is one which encompasses how the state mutation is handled, meaning that when you send a transaction, let's say from user A to user B, the balance get transferred from user A to user B. And how is that being handled is through this definition of account schema, where you have the user details, and lifecycle hooks gives you the ability to mutate this state from one state of the user to the next state. And we're going to use all of this concept when we do the workshop, where we would define the account schema for building supply chain traceability, and then we will use the lifecycle hooks to accept the transaction and then get included in the blockchain and mutate the state. So these are the the architecture for the on-chain. And we have the off-chain architecture, where, as I explained, you could interact with the blockchain and then listen to the events and then build your own independent business logic on top of this by invoking the actions to the on-chain logic, or by listening to the events and then observing the data. So let's understand how the application bootstrapping works and how we can utilize that to build our use case. So with the Lisk SDK 5.1.1, we have provided the ability for developers to bootstrap their own blockchain application quickly within a couple of minutes and develop the use cases. We also provide some of the plugins and framework utilities in order for you to visualize what's happening in the blockchain application, whether it could be transactions, blocks, and much more. And for you to use the testing framework to whatever the logic you write, to be able to test your logic. That is one of the important aspects when you have the blockchain, custom blockchain logics that you want to write. So you want some utilities for you to test your logic. And Faucet plugin is where, during the development stage, you want some mechanism to get tokens for your account so that you could use that tokens to make transactions. So Faucet plugin allow you to get these funds from tokens. And the bootstrapping allow you to create your own blockchain application. It also provides a mechanism for you to customize your application configurations, whether it could be application ports, or whether it could be the size of the block you want to include depending on the use case that you have, or it could be the number of we're going to use the delegated proof of stake consensus, and then you could either increase the number of participants in terms of delegates according to your use cases, so on and so forth. This allows you to customize your blockchain application based on your needs and use cases. And you could use the modules, assets, and plugin concept to add your business logic. So this is how the dashboard plugin would look like. It provides you ability to create accounts and observe the blockchain for the recent blocks, transactions, and then the unconfirmed transaction. And you have also the ability to send the transaction and query the actions to the blockchain and then get the data from the blockchain. So this is very helpful when you are in early stage of the development and then you want to quickly see how your development is going and then interact with the blockchain to know what's happening. This is being made feasible with the latest SDK. So this is the Faucet plugin that I was talking about. Here you could provide your address and then receive some free tokens for testing the transactions that you've implemented. Finally, the testing frameworks provides some of the utility for you to test your logics that you write for the module, assets, and plugins that we were talking about. And this eases your development where the Bootstrap already provides you the template. And on top of this template, we have utilities where you could use the utilities, and then based on the test case scenarios that you want to write, you could use these utilities and then write the use cases, test cases. So that's all for the presentation. And then now we move into the workshop. So today, as I said, we're going to use the supply chain traceability as a use case to demonstrate how you could use the Lisk SDK and build the blockchain application. So now let's take some time, and I will wait for a couple of minutes so that whoever is following the workshop and then has the laptop or the environment set up could follow the workshop later in time and then step by step. So I will hold for a few minutes, and then you could install the Node.js 12.22.1 version. The reason being we need a specific version is the package is being built and restricted to a specific version of it. And we also always follow the stable version of the Node.js. And at the moment, the stable version of the Node.js is 12.22.1. And yeah, that is the reason we need the specific version of the Node.js. And just confirm once you install the Node.js version, and then you can install then the Lisk commander, as I explained earlier. it is the gateway for you to bootstrap your own blockchain application and and develop on top of that. So I'm going to wait for another 2 minutes or so, and I'll look at the chat if someone has an issue. Yeah, I see some questions around how we could install. Yeah. Okay, I'm going to stop the presentation now and move to the terminal so that like I could start the workshop, and then you could still follow me there. I hope you've installed this. I've also provided the workshop installation gist in the Swapcard chat. Please follow that, and then if you face issue, please. If you're not able to follow in the later stage, you could still always come to the Lisk chat and Discord, where we could help you out, and then still you will be able to continue the workshop later in after the workshop as well. So I'm going to stop the presentation now. So as we discussed, I have my environment set up already, and I have the Node.js version required, and I also have the Commander version that I want for bootstrapping the application. So now that I have all the required prerequisites, I'm going to create a directory for the use case. And Lisk, if you look at the Commander, it has the global commands for you to create an account. This is useful for you to make any transactions or interact with the blockchain. And you have the generate command, which we will going to use for creating the modules, assets, or plugin. And we have many of the commands that you could check out by, let's say, for example, if you want to know how you could use the account, you could just go in the command and then use the help, and then you could also use the subcommands and then see all the examples to work with it. The one which we're going to use for bootstrapping the application is init, which will initialize and bootstrap the blockchain application. So let us go and use the init command, and supply chain traceability application. So once you run this, it will ask for you to, the prompt to answer the question. So you can either modify them, or you could, allow the existing name. I'm just going to continue with the proposal, and then this would allow me to create the blockchain application. Meanwhile, it starts to install the packages. We can observe what the bootstrapping has created for us. You can see the application is bootstrapped with all the configurations required for prettying or linting, from that to creation of test setup. And for development of application, you have modules and plugins. You also have commands for the interacting with CLI. And yeah, all of this is shipped with this bootstrap init command. And then it will also initialize the application with the dependencies required, which is what it is doing right now. And once the installation is completed, what it does is it takes the default application schema, meaning that the base protocol provides you for an ability to do a token transfer, use the DPoS mechanism for you to create and register delegates, and then many other features comes with it. It also has keys features which allow you to register a multi-signature account. And yeah, so on and so forth. So these are some of the things which is bootstrapped by default with the blockchain. And as you can see, the command is generating the Genesis block now, which is the origin. If you already know in the blockchain, like every blockchain has a Genesis, which is the origin of its starting point of it. And from then on, you will start seeing the next iteration of blocks being added on top of the Genesis block. So now that the application is bootstrapped, I hope you are able to get to this stage. So now we can navigate into the directory. And I'm going to run npm install global, because if you want to use the commands related to the supply chain traceability app that we created, you need to export globally so that you could run the command similar to what we did for Lisk. So now if I run SAT app, I could see all the commands that is available from the SAT app. So these are the commands that you could use later to, for example, you have console that I'm going to demonstrate and show you how you could use the console to interact with the blockchain. These are very useful for during the development stage for the developers. So yeah, and you have the start command, which we're going to use to, once we develop the use case, we're going to run the application using the start command. So I'm going to use the Visual Studio Code for the development of the supply chain traceability. And I'm going to exit from the terminal for now, and then I would like to move to the presentation now and explain you what the supply chain traceability challenge that we're going to see, and then what we can develop. So let's say supply chain in general is a vast concept, and then like you have much more in-depth details. But like in order for us to understand how we can use the supply chain use case to build the traceability using the Lisk SDK, let's say there is an outbreak with the foodborne disease. It can take several days to weeks to find the origin of the problem. So we need better traceability that could help at times save, if not tens to hundreds of people life. And then it could also allow you to trace the particular origin of the particular producer who produced the goods, and you could provide the meaningful feedback as part of that flow. I'm going to assume for this demo that let's say Reve as a retailer who provide these goods to the consumer, and a RandomX as a supplier who basically takes this produced products, who's in this case farmers who produce the products, and then supplies them to the RandomX, and then the RandomX will in turn supply them to the retailer. So as we talked, producer will produce the goods, and supplier will basically take these goods from the producer, and then based on retailers purchase order, he will fulfill the supply and then make the invoice for them. And then later, once the product is available in the retail, the consumer will go and consume these products. And then if everything is good, there's nothing to worry. So if there is a damage, or if there's a issue with the product, then the consumer can return the product to the retailer, and then retailer in turn can return to supplier, and we could track how the whole the flow is happening, and then how we could benefit from this traceability. So let's say Revy places an order with random X, and random X ships the order with the invoice. And then once the product is shipped, Revy has to pay to random X. And then consumer returns the damaged goods to the Revy if there is damage. And then Revy could in turn return the damaged goods to random X. And random X could settle the payment for the damaged goods to the Revy. So how are we going to build this use case is we're going to consider the minimalist approach and not take the whole the real world supply chain use case, but we're going to take the minimal part of it and then try to implement in the next 1 hour to demonstrate how you could use the Lisk ecosystem products solve the real problem. And yeah, later in the time you could go back and then see the whole documentation and understand and build concrete examples and even apply for the grant program as well. So we're going to bootstrap the blockchain application that we already did, and I'm going to demonstrate how you could add on-chain logic for the retailer, supplier, and the producer part of it, and yeah, also add on-chain, off-chain logic for tracking the metadata. So I've already followed the bootstrapped blockchain application step where I demonstrated how you could create the bootstrap the blockchain application using the init command and install it globally so that you could access the commands. I hope you're able to follow the steps and then able to bootstrap the application. Now what we're going to do is use the concept of the generate module and then generate asset, and then add the on-chain logic. And later, once we're done the on-chain logic, we will use the plugin concept to add the off-chain logic. So there could be many transactions required for us to achieve this full use case. In this case, let's say the producer has product with the product ID, name of the product, and date on which the product was produced, and there could be much more product metadata of that. And there is a supplier who has either invoice, payment, and for the retailer has purchase order that he made to buy some of the goods from the supplier, and the payment settlement for the supplier. And if there is a damaged goods, he could also have return order. And the consumer would either shop the product and then return in case of the damage. For today's workshop, let us take producer and supplier flow and then use the Lisk generate on-chain logic and then off-chain logic to add the supplier and producer flow. And you can extend the other part of the implementation as I showed consumer and retailer part after the demo as well. So let's say the producer has product, and then this is how the schema would look like for the data, and ID, name, and data. For supplier, he has a collection of all the products which he owns from the producer, which he sold to supplier. So now I'm going to stop here presentation and then move to the Visual Studio Code where I have bootstrapped the blockchain application. Some of you have asked if to increase the font size. I hope this is clear enough. I hope this is good enough. So let me know. Okay, so I'm going to open up the terminal and then make sure I use the right version of the Node.js. So I think a lot of people asking this question, why use the the specific version of the Node.js. So as I said, we always use the LTS version provided by the Node.js. In this case, it's 12.22.1 for all the production purpose. For the development, you could use the 14, and then you could still do it, but all the bootstrapped application comes with the specific version. So that is the reason why you have to use the specific version of the Node.js. And yeah, why the module ID could be greater than 1000? So I think that's an important question. So all the default modules that the Lisk protocol can provide, we need to reserve some, we provide the default modules. For example, we have token module, we have keys module, depos module. As I explained, token module is responsible for transferring the tokens from user A to user B. So we have these default modules as part of the protocol itself, which we want to reserve for the future, where we could have developing few more modules from the Lisk ecosystem itself. And we want the developers to utilize the module IDs beyond 1001 and add the customization on top of it. So that is the reason why you have a specific module ID number. And so I had to install. Okay. So okay, I'm just switching between the swap chats to see if there is any important questions, but I hope I can move forward with the bootstrapping of the modules that we talked about. So you could bootstrap your own modules using the command list generate module. And as we said, we're going to introduce two modules. One is the producer with ID 1001. And what it will do is it will generate the module for implementing on-chain logic related to the producer. So if you run this command, you would see the application has, inside the application, you have now modules with producer. So let's go and look inside what this module would have. So by default, the Lisk SDK would create this template for you, and then you would also have the bare minimum required for you to get started with the development. And let's follow from the top. So actions are something which the plugins could invoke from the off-chain, and we saw that module is an on-chain logic. So the interaction between the off-chain and on-chain is happening through this channel, and it's invoking via the action and then getting the details it's required. So you could add these actions and provide, let's say, for example, if somebody wanted to know the balance for a particular user, and you could expose the actions like this and then provide the user with the details. Reducers are something where when you have to interact between modules, so which we will do in case of the producer and the supplier, where the supplier need to acquire the products that producer has produced. And we're going to see how we will use this concept to interact with the modules and then use the logic to interact between the modules. And then you have a unique name for each module. You have assets for the module. What are assets is basically it's a mechanism for you to manage your state mutations for the particular module. Let's say the producer has products, right? So in order for you to create new products or give the products to the supplier, all of this logic is can be achieved with the assets that we're going to create further down. And as I explained, we have events as a mechanism to notify the other parts of the either framework or the outside world who is listening to these events via the implementation of events. This is the unique ID that we used to create the module. And we have constructor where you could initialize the module with certain specific module specific configuration. For example, let's say you wanted to build a module where every 1000 blocks you wanted to give someone a reward, or any random mechanism that you want to build. You would provide the specific configuration and then use that configuration in the lifecycle hooks to achieve the business logic. For example, let's say before the block apply, so we have certain blocks lifecycle hooks which you could use for blocks to transactions. So block contains list of all the transactions, and before any block is being created or processed, you could add the business logic in these hooks and use these hooks as a mechanism to achieve your business logic. Let's say you wanted to notify the user before the transaction executed that the transaction is being processed, and so on and so forth. Then you could say before transaction apply, you could do something like that. And yeah, same thing can be done once the transaction is processed, you could also use this hook to notify the transaction is being processed, and then here is the status. So this is the flexibility that the module provides you to from the beginning of block processing till the end of the block processing, and then beginning of transaction processing till the end of the transaction processing. So we have these hooks to implement those kind of customization. So now that we understood what module is and what kind of actions reducers or the hooks that you could use, let us go and add the asset for the module. So let's say we want to generate an asset for the producer module, and we want to create a product asset, and the product asset ID is 0. So why do we need to provide this asset ID? Is because so each asset is unique within the product. So, and it starts with 0, and then you can add up to n number of assets you want for your module. So let's now go and look into the asset. So as you can see, the producer now has one asset, product. So the product has the schema defined, which we're going to use and define all the required properties to be able to process the transaction from the user, and then keep the products in the producer's accounts. So we have few more hooks and functions here for you to validate. Let's say when you send a transaction, create product, let's say, then you want to first make sure the transaction that you receive is statically valid, and you could use this function validate to validate if the received transaction is valid. If the transaction is invalid, you're going to reduce you're going to reject the transaction at this stage itself. We will implement some of the validation step here, and then we're going to also implement the apply step. This is this hook where your transaction is being mutating the state, and then saving once the block is generated. So that's about the module and asset. So now let's go and add the other two module and asset required for use case. The other one is module supplier, and then since we use the 101 for the producer, let's go and use 102. Now we have this supplier module, and let's go and add the transfer of the asset which the producer has produced to the supplier. And let's give the ID 0. Oh, forgot to mention, you also need to provide the module. In this case, it's supplier module add transfer products with ID 0. So now we have the two modules that we require in order for us to able to create the farmers can now create whatever the products that they create. They could use some other service. For example, let's say one could use a barcode application that is being built, and then simply they could scan the barcode, and then that could in turn create a blockchain transaction and post to the blockchain. The farmer doesn't need to know what a blockchain is, and then he doesn't need to know anything of it. You just need to know a way to send the metadata required for the product and then store it in the blockchain so that we could track the details of it. So now that is being achieved with the producer module and then the product asset. And now the supplier can acquire this product once the producer is intending to transfer this or sell these assets to the supplier. So I hope you were able to follow this step and then create the modules that is required. I'm going to just look into the chat and see if someone has still issues, and then move on to the next steps. Yeah, I see like some of them has issues with the installation setup. Sorry that if you were not able to, some of you are not able to follow the installation. I hope you could still catch up once you have done the installation. Yeah, I hope you're able to, I do not see anything, questions related to the module creation or asset creation. And yeah, if you didn't face any problems there, then let's move on to the development of the module and asset. So as I said, we need the schemas defined. So we need to define schema for the asset. We need to define, since we're using TypeScript, we need to define some types for us to utilize the asset for validation and the apply steps. So let's go and add these properties. So as we said, the producer would have a product with unique ID identifier. I'm going to simply consider some generic ID and then name of the product and then date. There could be much more metadata than this. So, and let's go and add what this properties are, meaning that what type of data type it is. I'm going to say string. And so we also need to specify in order for us to serialize the data in the correct order and then deserialize, we need to specify the field number. So what field number does is basically when you send this transaction, these transactions are being serialized and then communicated via the peer-to-peer network. In order for us to deserialize in the same order that the data was serialized, we need to specify these field numbers. So I'm going to use the same metadata and then add name, also add string, and date. For simplicity, I'm just using the same data type. It could be you could use other types of data. For example, If you want to use numbers, you could use uint32. If you want to use big ints, when you have, let's say, the amount and then the numbers are, it can be bigger, then you could use uint64. You could use arrays, and you could use all the data types available. But for this purpose of this demo, I'm going to use the simple data types, and yeah, just move on there. So now that we have the schema, let's go and define the type for interacting with this product. So as we define the schema, the product can have ID, name, and string. And the producer you can have all the products associated to a particular producer. Let's say me as a producer, like now I have 10 number of products that I have available with me. Then I have a collection of those products. So now that we have the types available, let's go and add the logic for validating. So I'm going to use the product type that we're going to use. And then now let's add the logic for validating. So for static validation, it could be validating the type of the data or the values that you expect to. It all depends on the use case. But for now, let's say we want to validate if the name of the product is a valid string with characters and numbers only. So we could say something like, if it's within A to Z and A to Z and 0 to 9. So we're going to test the name of the asset is within that range. Otherwise, you could say throw new error and invalid product name. And so what this does is, when a user tries to send a product transaction to the blockchain, and then if it is not complying with the validation that you expect, then the transaction is being rejected with this validate step. So this is just a simple example. You could go and extend these kind of validation steps depending on the use cases that you implement. So now that we have the validation logic implemented, let's go and remove this throw part. So let's use the type definition. Now in the apply step is where actually the transaction is being processed, and then the state of the account is being mutated and then being updated. So in order for us to do that, so first we need to get the account of the sender who is sending the transaction. So validate if the product already exists. So the user could be sending the same product which is already there. For us, product ID is a way to know if the product is unique. In this case, it's just a string, but in theory, you could define a barcode which is very unique for each product, which allows us for exact traceability by product. Let us go and assume that the ID is unique here. And then once the product is confirmed that it doesn't exist, then we're going to save the product. To the sender account. So how can you get the account is we have this state store interface for you to interact and then for a particular account, and we have all the interfaces for you to do the required necessary logic. For example, in this case, I want to get the product of the sender that is being sent the transaction. Let's say in this case, the transaction sender address is the producer farmer 1, let's say, and we want to get the whole account details of the supplier, the products that the producer holds. So once you get the account, you could see what the sender account has. He's a producer and he has the products in his accounts. So now we could validate in order to check for the uniqueness, you need to check if if it already exists. So let's say user.products. Let's find the product. If the product is matching with the transaction that is being sent, we can throw the error that so this is a stateful validation where what does stateful validation mean here is in the static validation, you are not accessing the state of the blockchain application. You're only doing validation against static validation against the asset that you've received via transaction. But in this case, in the apply step, we are using the actual state of the blockchain by querying the account of the particular sender and then checking against the state if certain business logic criteria needs to be met. In this case, we want to check if the asset already exists or not. If it exists, then we're going to reject that transaction. So if not, then what we could do is sender account dot producer dot products, and we could save the product the user's account. The name and so now that we validated and then inserted to the user account, the final step would be to use the state store interface and then save the data. So for that, we're going to use the set interface, and then if you see the set interface, it requires for you to provide the address and then the updated element. So in our case, the sender account is being updated, and then we're now saving the transaction after the validating steps. So what you saw was here is in the first step, we were able to validate the transaction statically. And then when the transaction comes into the final stage of being saved into the block, you're now checking the other business logic and then updating or mutating your account state and transitioning it to the correct state. In this case, you're adding the product to the producer products account. So I hope I'm just going to now move back to the swap chats and see if anyone has any questions, or then I would continue to the supplier step. So I have see some questions. What about sorting of arrays and unambiguous serializability? Do I need to sort them to my own? No, you don't need to sort the properties. We use we have our own codex library, which basically looks into the schema that we define. For example, in this case, we have the schema defined. So whenever we provide, let's say, the transaction with, even if you don't provide the data in the order, I hope your question was around the same. So even if you provide, a data like this, it would be fine, because what you are ensuring is the order. You're specifying the order, and then the serialization will internally take care of this by taking the data, and then it internally handles that part for you, and then you need not worry about them. But what you need to make sure is define the required properties properly. If you expect the user to provide, let's say, the name, date, and I don't know, like other address of the exact location where the product was coming from, all of this detail, you need to use these required properties to specify them. And then inside the properties, then you go and define additional validation and then serialization mechanism for that. You could also use, for example, let's say I want to specify the length of the name that they provide, right? I don't want any user to provide the name of the product to be the huge length. Then you could use the JSON schema validation and use something like min length, and then provide what is the length that you expect. So then these kind of validation can be taken care through the schema. And we use the JSON schema definition validation, so it is industry standard. And then these field numbers is something specific to the Lisk serialization protocol itself. I also see another question: when are plugins more appropriate? Use them than modules, and vice versa. I think plugins and then modules are two different concepts. As I said, modules, you'll use the modules as we saw. We are now extending the blockchain application, the delegate proof of blockchain application, to introduce the supply chain traceability. You could achieve this supply chain traceability. You could track the products and then include them as part of the user's account, and then allow you to have the data tracked in the blockchain forever. And this is something on chain. It has to change. This data has to stay on the chain forever, right? In order for us to do that, you need to use the concept of modules for you to isolate the business logic. So module encompasses the isolation of the product, the domain. For example, you have producer and supplier. They're two independent domains. So you isolate this business logic with the concept of these modules. Whereas the plugin concept allows you to observe the activities happening on the chain through the actions and events, and it could build a metadata I will show you later in the time how we use the dashboard plugin or HTTP API plugin to query the API or use the HTTP server and dashboard as a mechanism for you to interact with the blockchain. For example, we will create this product with the dashboard plugin and send that data to the blockchain via from off chain to the on chain. I hope I answered your questions. I'm going to now move on to the supplier part, if you guys are still following them, and then define the asset. So in the interest of time, I've already prepared some of the schemas for this, and then I'm going to just reuse them. But I hope you still now followed how you could define the schema. So let's take the schema for the supplier. So we need to define this for the module and account schema. So what does it have is, let's go and see what this each property mean. So now the supplier would have all the collection of products that the producer has selling to the supplier. So the ID, name, date, the recipient address, and the producer address. So the recipient address is the one who basically received these products as a supplier. Supplier can be like, there could be n number of suppliers. Coca-Cola is a supplier. There are n number of suppliers. So each of the supplier can receive these products from different producers, and producer's address is the one which is mapping to the one who is selling these goods to the supplier. So you could track this information when he transfers his products to the supplier. So now that we have the schema for the supplier, so I'm going to use the schema for transferring the products. So what we see is when the producer wants to transfer his products to the supplier, he would define the name, ID, date, and then the product IDs that he wants to transfer. Let's say he produced 10,000 mangoes or apples, then each of them has its own unique IDs and whatnot to traceability to that point. He could provide all the details and transfer all of this product to the supplier. And this is how the schema would look like for the transaction. And I'm going to also add the schema for the producer. In this case, so we have now all the schema necessary required for us to go and implement the product creation and then the transferring of the products. So let's say if the product needs to be transferred from user A to the supplier, then we could go on and then define the interface for the transfer producers. Again, I have the schema types definition defined for them. So we have the ID, name, product IDs, and recipient address, and the interface for the collection that we saw in the supplier module. And the supplier would have the collection of items that he got from the producer. So I'm going to use this transfer product and use some similar validation technique. Once again, the validation can be complex depending on what else you want to validate. Let's say if you're receiving the phone number and address and many more metadata, right? So the validation logic completely depends on what kind of data you are expecting from the user as part of the transaction. So since this is, we only have the username, the name of the asset, so I'm just using this for validation. So now we can use the transfer product and then see how we could transfer the products from the product which the producer owns, and then transfer them to the supplier's account. So if you observe here, the products that the producer owns is in the product account, right? And then now it's two different domains now. So as I mentioned earlier, if you want to interact with two different domains, which is the producer, now the supplier needs to interact with the producer to get the products that he owns. So we need the concept of reducers, right, as we discussed earlier. So I'm going to define a reducer through which we could interact and then get the data transferred from the producer to the supplier. So let's go to the producer module. We have reducer section here. So I'm going to define the transfer reducer, which takes similar parameters that we defined here. You can pass in what you want to transfer from the other module, and then the state store, and you basically want to return the products that you want to transfer. So we need the product interface now. So let's quickly get them from the other module, so which is the product asset. And let's go in and implement how we could how the supplier could enable the supplier to the producer to transfer his assets. So yeah, this has a bit of logic to it. So I'm just going to use the implementation that I already have. So let's quickly import the state store definition. I'm just to minimize this. So you could see the the producer, the supplier would use the transfer reducer and then pass in the product IDs that he wants to get transferred from the producer to supplier. And then here we could check if the address is in the right format, and then we could so we need to import the producer from the let's quickly import the type from there. And so now we have the interface to interact and then get the product that the producer owns. What we're doing here is iterating through the products that he wants to get transferred. For example, in this case, he wants to transfer the defined product IDs and then transfer them to the particular supplier. So here we are iterating through the product IDs and then getting all the products and then storing them in an array of transferable products. And then what we're doing is we going to filter out the ones that actually now being transferred to the supplier, and then update the products in the producer account. For example, let's say if the producer owns 2 items, let's say if if the supplier requests for these 2 product IDs, then he gets transferred the one product, and then the other product is saved, and then now the producer has only 1 product, and then the other product is now transferred to the supplier. So I'm just going to update the interface here to be able to save. And with this mechanism, now modules are able to interact and then query the orders. So let's go ahead and implement the other part of the transfer being done. So what you could do is get the products of the supplier. For example, when we receive the transaction from the supplier to transfer this product, so he gets basically the account of the recipient who is going to receive this, and then he's going to invoke this reducer handler. So the apply has a context of asset, transaction, state store, and reducer handler. So reducer handler is the one which allows you to interact between modules. So you could invoke all the reducers defined in the module, and then in our case, the producer module has a transfer reducer. So here we see that the producer module has a transfer reducer, and then the supplier is now able to interact with the producer module and then gets the products that he wants to get transferred to his accounts. I see some issues here. So let's go ahead and see. Okay, now we have the producer products account. So then I see some data being missed. So let's go ahead and try to add them from scratch. So let's say we have now the product that we got transferred, and we need to add the date. Oh, okay. But I think we imported the wrong phase. So what we wanted to do is actually transfer this produced items. So in this case, it's the collection. And whatever the collection that the supplier is holding, we will transfer it from a particular producer and then save them in the supplier's account. So at this stage, the products are now transferred, and then finally we would apply the supplier collection with all the products that we received from a particular producer. So that completes the implementation for producer and then supplier. So let's remove the unwanted code. I hope if you have any questions, so I'm moved to the Swap chat and then ask. Okay. For those who try to keep up with the code, Manu had some schema. Yeah. Yeah. Thank you, Rowan, for sharing the schema. And then I would also just share the types and schema that produce. So there is a question from Simon. Do the functions we have implemented behave transitionally? So if something fails in the middle of a reducer, the result doesn't get applied in the chain. Yes, that's a very important point. So what Simon is asking is, so let's say while doing the apply step, so the transaction is rejected anyway during the static validation check, right? So so basically the flow of the transaction is, transaction comes to the transaction pool, and then it's get added into the block. When the producer wants to generate a block, the delegates, he will pick up this pool of transactions and then try to include them in a block. If the transaction is invalid, then the transaction will be rejected, and which means it will not apply the state changes associated with that if there is any violation related to the implementation that you specified. So that's an important question to note. I hope that answers the questions. So now what we will do is, so we have now the producer and supplier in place. So let's go ahead and update the application to cater this. So here, if you observe, we created two modules, right? So the bootstrapping application already allowing and registering these two modules that are generated automatically. You don't have to worry about this part, and it is taken care of automatically. What we have to do is, remember we talked about the Genesis block, which holds the schema for the origin of the blockchain. When we bootstrap the blockchain application, we didn't have the producer or the supplier, right? So for example, if you want to see how it looks like, so if you see the Genesis block, what you see is you have the accounts. So it has the token module, sequence, keys, and depots, and it doesn't have the supplier and the producer, right? So in order for this to be included, what we have to do is, before we create the application, we need to update the Genesis block and the configuration for us to run the application. So what I'm going to do is use this. I have already created the data for it, and then I'm going to just use that and update the application, and I'm going to explain you what exactly it's all about. So let's go ahead and then copy this. So let's import the util function required. Here we need the utils in order for us to merge the configuration. What is it doing is basically it's a utility function. You have a lot of data structures and then object related functionalities for you to work within the blockchain. For example, you need to deal with a lot of buffers, cloning the objects or merging the objects. So in our case, we want to merge the configuration, so we use the merge configuration. So what I have done here is, so I'm iterating through the accounts that I just showed you. So I'm going through this list of accounts here, and then I'm trying to add the producers, products, and supplier collections. I hope you were able to map what I was trying to do. So we need to update this Genesis block in order for us to start the application. Otherwise, you will face errors. So what here I'm doing is like, again, updating the application configuration with some the labeling and then customization of the labeling, or enabling the logger, or I'm going to use the RPC to demonstrate how to interact with the console, and for enabling the faucet plugin, and so on and so forth. So this is something you could follow on the documentation, and we have the detailed documentation for you to do the step by step. For now, I think you don't need to worry. So let's go ahead and then update the application config. So what it has done is you have the application is being now updated with all the module logic that we have defined, and then the next step is we will use the command to run the application. So what you see here is like a start command. Either you could use bin run or you could use the HCT app, because we exported them globally, and you could run start and then enable the faucet plugin if you would like. So for now, I would just say API WebSocket, and for you to demonstrate how HTTP a plugin works, I'm going to enable this plugin that by default the framework provides. You could add your own plugin logic using the generate plugin command, but you could also enable the existing plugins. Let's also enable the dashboard plugin. So with this, if we start running, looks like Genesis block doesn't match, because there might be some schema changes that we need to look into. So let's go ahead and just cross-verify the schema. So we define the schema for accounts. So we have the products, and yeah, that looks good. For the supplier, we have collections, and that also looks good. So we have products and collections for the supplier. I hope I didn't modify the Genesis block. So looks like there is some issue with the Genesis block. Okay, so what I'm going to do is quickly switch to the one that I'm already prepared working, and then it's almost in the same state. Let's open that up, and then you could see it has we have followed the similar step, and so I'm just going to show you. Yeah, so if you see here, I have the similar logic, and then I'm updating the products and then suppliers, and the config is updated. So what all we have to do is run the start command. So as you can see, now the application has started, and then you're able to see the delegates are being active now, meaning that delegates are the one who create these blocks. In proof of work, you have miners. In delegated proof of stake, you have delegates who creates the block. In proof of authority, you have authorities, fixed number of authorities who create the block. So this whenever they receive the transaction, so that in our delegated proof of stake, we have blocks being generated every 10 seconds. So if you see here, every 10 seconds.
Hey, Georg here. I just want to interrupt you real quickly. Your screen is super blurry, and we cannot see it anymore. So maybe stop and restart the screen sharing. That would be great.
Oh, sorry. let me know when you start seeing the screen. I hope you're
now
able
it's
to see the
perfect
screen.
again. Yeah, so I can see it. Let me check if the participants looks good.
Yeah.
So
I would quickly jump back and then explain where I maybe it stopped. So what I did was ran the command to start the application, which in turn enabled the delegates to create the block and you know uh, generate the blocks every 10 seconds, as I mentioned. So if you see here, every 10 seconds, the new block being generated, and then the height is moving along. So we don't have transaction at the moment. So what I'm going to do is now again, unfortunately, I have to switch to the browser to show you the API and then the dashboard plugin, how we could utilize and then send the transaction. So meanwhile, I would also show you when we create the blockchain application, we also provide you with some default accounts under this secret folder. What is this giving you is like the passphrase and then the address required with let's say 1000 LSK tokens, not the production tokens, but like for the development purpose. You could use these accounts for transactions, as I said. Like now, let's say if I'm taking this user as a let's take user, let's call him user 1, and then I'm going to say this as buyer account, right? And then we could use these accounts to make the transaction, and we'll demonstrate how you could use the dashboard. So I'm stop sharing now. So I'm quickly moving back to the dashboard. I hope you're able to see the dashboard now. So if you observe here, the dashboard has all the functionality that we talked about, right? Like it's monitoring the blockchain and then providing you the information. Let's say time to the next block, the height is being incremented, and you can create an account for interacting with the blockchain. So these accounts will be stored here, and then you could still copy them. So you could click on them and then open. You could watch the recent blocks that is being happening here. Once we send the transaction using the send transaction palette, then you will see the transaction go from unconfirmed state, which is in the transaction pool, and then once the transaction is included in the blockchain, it goes to the recent transactions where the transaction is confirmed. So let's go ahead and then let's say we said we have the producer account. I'm going to use the passphrase of the producer account. And so if you remember, we added 3 properties: unique identifier, which is let's say 1, 2, 3. This has to be in real world proper unique ID, which is very unique. And in case of the name, let's say mango, and let's say the date is today. And also again, this date can be very a valid one, and then for now demo purposes, let's take a simple version of it. And so these are the details that is required. Now what will happen is when I submit this transaction, the producer accounts is get updated or created with this product. Let's go ahead, let's say one. So looks like the product ID already exists, one, right? So we implemented a validation check to say check if the product already exists. We want the unique product, right? So let's say we have one. So now the transaction is successful. So what you saw was you have a validation phase where it's checking if the transaction that you are sending is valid, and if it applies, it abides by all the rules that you define. And then if it is valid, then only it gets included in the blockchain. And now, as you saw, the transaction went from unconfirmed, and then it get included in the blockchain. So now let's say if I want to query this transaction, what I could do is, there is this palette for you to interact, get transaction by ID, right? All you have to do is provide the ID, the transaction. Maybe the ID was incorrect, but yeah, I got the right ID from the transaction that is confirmed. So if you submit, then you would see that in this particular module, this transaction that we posted was included in the blockchain. So now let's go ahead and so you saw how we were able to use the dashboard plugin to interact with the blockchain and then query the blockchain and monitor all those things. You have another palette for, let's say, if you want to watch every block that is being created. So if you subscribe, you could subscribe to many more. Let's say if you want to subscribe to the new transactions, then every time the event is published, as we saw the lifecycle hooks, you could use this lifecycle hooks to emit events as well, and then let the user want to build any services around that data. They could utilize that data, event data, and then build on top of it. So now we have subscribed to the block new event and then transaction new event. So whenever I submit a transaction, let's go ahead and then submit a new transaction. So if you go and see here, so whatever the transaction I sent to the network, you were able to listen, because whenever we send the transaction, now it is observing this transaction and then emitting the event for you. And you could, this is the transaction hex encoded. You could decode the transaction with the schema that we defined, which is the ID, name, date, and the transaction schema. So now let's, I'm going to stop this and then switch to API. So we have, when we run the application, we enable the dashboard plugin API. You could also enable faucet similarly. So here you have the HTTP API, which giving you the endpoints. This is a plugin, HTTP API plugin, which is basically querying the blockchain and providing you all this metadata. For example, what are the registered modules? We have token, sequence, right? And then we have the new modules that we implemented. So if you see the IDs of them is it's below 1,000, and then you have the IDs that of the new ones we created as like this. So let's go ahead and then check out the accounts of the producers who owns this product, right? Now the producer with this address owns these many products that we created. So what we could do is, let's take a supplier account. I'm just going to show you how it gets transferred. So here we see this account is the supplier. He doesn't have any supplies at the moment. Let's transfer some of the products and then check if you receive them. Sorry, unfortunately, I have to keep switching. Demonstrate, yeah. So let's go to the dashboard plugin. So now let's use the supplier. and let's define what needs to be transferred. So we want to, the producer want to sell some of the mangoes that he owns. Let's say he had want to send bunch of the collections. We saw one, and then the one who gets these mangoes is this recipient address that you specify. For example, you want to sell. Imagine this is, I don't know, like some supplier and his address. Then you could provide the details and then provide you're selling the mangoes of these products, and then looks like something is wrong with this. Okay, something is invalid. The schema, I'm just going to check the data is yeah, unfortunately, I'm not able to use the product IDs, but like I'm going to show you the products that I was able to successfully transfer. Let's say I transfer to this account. So what I did was I used the account, and then I was able to transfer the product that the supplier owned to this is the producer who produced it, and then the recipient account received these mangoes. And you could have the supplier could have much more collections. You could imagine the collection could be big enough, not just one, from different producers you could have many more collections. So this way what happens is when we have the retailer and then the consumer part, then you could track from the beginning of the producer up until the consumer through this recipient and producer accounts, and then all of this. And then you could also track the date in which it was provided. You could also add much more data, for example, the location, exact location where it came from, the region of it. Let's say if let's say the banana is from South America, and then someone who's consuming in the Europe is allergic to some kind of bananas, then you could easily trace where the origin of the product was through this mechanism, and rectify the problem. And then if you see and then you could also notify others. So this is what the Lisk blockchain ecosystem enables you to build your own application use case with few minimal steps. Yeah, so that's about it. I'm going to now conclude the workshop now, and then I would like to switch to the presentation part of it. So what we saw was we were able to see how we could implement the supply chain traceability from the origin of the producer up until the consumer when you extend them, and then we could identify the shipments. You could notify the retailers or the users. So basically, this allows you to track the products in in much more sensible way than in the current approach, where it could take weeks and months if you don't know the full the trace of it. So why do we have to choose Lisk system here? I think you by now you know that how easy was it for you to bootstrap your own blockchain application, meaning that you didn't need much knowledge around what exactly you need to know about consensus, or how the state is being transited. All you had to do was some of the functions and utilities that the Lisk SDK provides, and then quickly bootstrap your ideas with the Lisk ecosystem. We have the protocol features which allow you to use the dynamic fee system. For example, you could pay as little as per byte. You could also configure for economical reasons, based on if you want your user to pay as low as I don't know, like one LSK, or even in BEDOS or of your own kind of tokens, you could configure that as well. And the Lisk SDK at the moment allows you the scalability in terms of transaction can be processed up from 11 to 75 transactions per second, and up to close to 1 million transactions per day. That's a huge number, because when you want to implement such kind of use cases, for example, let's say you want to build the real world supply chain traceability, right? You have tons of products. You want to uniquely identify each of those products, and then in order for the producer and all the other users to use the ecosystem efficiently, you need scalability, because you want to able to your transaction to be processed quickly within a few seconds, and this is being enabled by the Lisk ecosystem. And yeah, with that I would conclude my workshop. I hope it was informational, and then I hope you learned something within this one and a half hour session we had today. And then I would encourage you to approach the Lisk chat, where we have the great community members, where you get answered all kind of questions. The Lisk team also is engaging day to day, and then we answers everyone's questions, and then help you out with your problems, challenges, or any information that you need related to development. And read the Lisk docs. We have wonderful docs, a step-by-step guide for you to build the use cases. With that I would end my talk. Thank you, George. I would now, if there's time, I would like to take Q&A questions.
Of course. Thank you, first of all, Manu, for this very insightful workshop. Also, thank you for already answering some questions during your talk. We have a couple of questions in the chat that I think weren't covered yet, so we will jump right into it. And the first one, and I think you didn't answer it already. If so, please just correct me. It is from Simon, and he asks, when are plugins more appropriate to use than modules, and vice versa?
Yeah, I think I kind of covered it briefly, but I can go over it again. As I said, modules are for your blockchain protocol related ones, where you have, let's take the supply chain traceability example, right? So if you want to know, let's say if without this with this immutability, and then all this thing which blockchain provides, you could record your transactions in the blockchain, and then anyone, any user, it can be supplier, retailer, or a consumer, anyone could track the data for the truth of it. So that is the important aspect of it. So this allows openness, and then all this logic needs to be tamper-proof, and then it should go into the on-chain logic, which is where the modules comes into play. Whereas the plugins, they can act as a service provider for, for example, HTTP API is a very good example of that, and dashboard example as well, dashboard plugin, where you are able to use the plugin as a mechanism for you to interact with the blockchain. Not necessarily it's protocol related, but it is allowing you to interact with the blockchain and then enhancing the user experience to interact with the blockchain. So you could think of building services related to user experience or other services. For example, I said if there is a outbreak because of the problems with the supply, you could build some plugins to monitor this kind of data and then notify the other users. This could be one example of a plugin. I hope I was able to answer to your question, Simon.
If not, feel free to follow up on that question in the chat.
Yeah.
Another question that just popped in at the end of your talk from Martin. Can I verify that the module's source code is the expected one as client?
What do you mean by the client? So if you're talking about the blockchain client, so the modules that you let's say you create the modules and then you provide this blockchain client to other users. For example, let's say you are a delegate, you are a participant of the network, right? So which means you are responsible for validating the block. So that means we all have the same source of truth. In this case, let's say if I'm tomorrow building this supply chain traceability decentralized application, then what I would do is the same client code being shared with all the users open source in an open source manner, and then everyone would run the same client. So that allows us to have the same source of truth and same client, which allows you to process the same transaction in a same in the same order. So yeah, I hope that answers your question.
I think so, yeah. And a follow-up question from Giacomo. So for the client, we should create a different app because this was only the server.
Okay. So maybe he was talking about this client server. So maybe what you were talking about is blockchain application and then the front-end client application, I guess. So one is we provide this on-chain plugin mechanism. You could either do it, managed within the same process by the application, or you could write your own front-end application as well. Dashboard plugin is one such client application, which is bootstrapped within the application. When you start your blockchain application, you could simply use one single flag to enable your client application as well. But you could also do it outside of the blockchain application as well.
Great, thank you so much for asking these questions. Let's just wait 1 or 2 seconds if any other questions pop up. In the meantime, let me take the chance to already thank you for participating with this workshop. I think it was a great way to start into the day. Thank you so much for joining us here at WeAreDevelopers. Maybe last question from my side. Apart from joining the amazing Lisk community, if any of the participants want to reach out to you, what is the best way to reach you?
So I think the best way to reach is the Lisk chat, as I said, Discord. We have different channels. You could always come into developer, or if you have general questions as well, you could post there. You will get your answers very swiftly and quickly. So you could always tag us and be always available for your answers and help you with in terms of development, or if you have any understanding how to bootstrap your application, or understand how the whole blockchain works itself in general as well. We want more and more developers utilizing the SDK and building their own, conceptualizing and building their own use case to solve the real world problems. Discord is the best way, I would say, to reach out to us. Great.
Then thank you so much for taking that time, for starting the day with this workshop. I hope you had the same amount of fun as we and I did, or even more. Have a great rest of the day. Have a great rest of the We Are Developers Conference if you want to join us for some other talks as well. And the same goes for the rest of our participants. Thank you so much for joining this workshop. I hope you had a great time, and more importantly, you will continue to have a great time at our program. So have fun at the next workshops or talks or sessions.
Yeah, thank you. It was really wonderful attending the WeAreDevelopers. I hope everyone gained some insight into blockchain, and then I look forward to the next year WeAreDevelopers event, and then go further into our interoperability solution. And yeah, I think it's very exciting.
And hopefully we will see each other in person, like the real event with
real
people
event
sitting in front of us. That would be great.
That would be great. Yeah. I had a really good time. Thank you so much once again, George, and then I wish you a pleasant day ahead. Thank you.
Great. Thank you, Manu. See you soon.
Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.